Hi, John Luke.
Really?
All right, so we are going to go over, first we're going to do a quick review from section 7.1 because there are a couple things that I need to remind both periods of. So we're going to review first what the critical values are when you're looking at confidence intervals. So when you take a confidence interval, you always have your point estimate. In most cases, it's the mean. But as we learned before, it can also be the proportion. And then you're going to plus and minus it by some critical value times the sampling error. So in proportions it look like this, some critical value times sampling error. When I'm working with means, it's always the sample mean plus or minus. Like if I wanted 95%, this would be 1.96. That's what my critical value would be. Times the standard deviation divided by the square root of n. When I was working with proportions, like on the worksheet, just a note about the worksheet. On Canvas, there is a complete key to the worksheet with explanations in a voiceover, narrated key. So if you have questions about the worksheet, or if you want to check your answers on the worksheet, you can go to Canvas and look over that. So on Canvas, there's a video that has a complete voiceover for that key. So, so we're going to go from, like the worksheet, we'll have our p-hat, which is our sample proportion, plus or minus. Again, if I was doing 95%, I use a 1.96 here. And then my sampling error for a proportion is the square root of p-hat times 1 minus p-hat all over n. So this is how you build the confidence intervals, the two confidence intervals that we already know how to do. Like I talked before, there are 4 types of confidence intervals that we're going to learn. There's 4 sections in Chapter 7. So this is all going to be on Canvas, so if you don't get a copy done in time, that's fine. We'll export these slides to Canvas. Right, so first you have means. And there's 2 types of confidence interval for means. There's a z-interval, a normal interval. And this is the type of interval you use when sigma is known. And then there's another type we're going to talk about today, which I'll get to. And then if you have proportions, that's when you have p-hats. You're going to use a 1 prop z-interval. And this is when you are looking at percents. And the last type that we'll do next week is when you're looking at standard deviations. So those are the 4 confidence intervals that are in Chapter 7. The types of means when the standard deviation is known, when sigma is known. A type that you do when sigma is not known for means. Proportions, like we learned on that worksheet. That's when you have a percent, and what percent of you like green shoes, what percent of you voted a certain way, what percent of you are male. Those are the 4 types of intervals that we're going to do. I want to review how you find critical values for z-intervals. So to find a critical value on a z-interval,
Why are you moving? Because it was out of right where you are. Can you see? I can't get exact.
So to find a critical value for z intervals, what you're going to do is you're looking for what are the two standard scores, the two z-scores that contain the percent that you're interested in. So for 95%, I've told you that critical value is 1.96. That is because if I go on my calculator and I look at the area that is between negative 1.96 and positive 1.96, I get 95%. I'll show you that here. If I go to normal CDF and I choose negative 1.96 as my lower limit and 1.96 as my upper limit and 0 and 1 as my standard deviation and hit enter, notice right here I get 95% for my area. 0.950000 and then a 4 little rounding error, but it's 95%. So the critical values for a 95% confidence interval is 1.96. It's symmetric. It's always going to be a plus and a minus 1. The minus 1 gets you the lower limit and the plus gets you the upper limit. Now I want to find the critical values for maybe an 80% confidence interval. So if I have a curve, looking at the middle 80%, so Matthias, how much is on the curve outside this way?
20.
20% out here,
10.
which means that we have 10% divided on each side. If I'm looking for this number right here, I'm going to go inverse normal up to that point. So on my calculator, F5 inverse normal. My area is going to be 10%, 0 and 1 because it's a standard normal curve. And this critical value is negative 1.28. Because it's symmetric, the positive one is going to be 1.28 as well. Now if I wanted to find that one, I would not put 80 as my area because I have to go all the way from down here up to the point I'm looking for. So that's 10% plus the 80 in the middle. I have to put 90 as my area. If I go inverse and put 90 as my area, hit enter, and I get positive 1.28 as my answer there. So these are the critical values for 80%. I would recommend that you write down the critical values in your notes for the following confidence intervals that are the most common ones that you need to have. 80% is 1.28. 90%, 1.645. 95%, 1.96, 99%, 2.58. You will notice that these critical values work for when you're looking for means. For means, if sigma is known, so they have to give you the population standard deviation in the problem, and it works for p-hats, proportions. It always works for proportions. These are the same numbers you used on your worksheet yesterday. When we did 99% and we had that sample size of 100, you used 2.58. It's the same number. The critical values are the same for both the means when sigma is known and proportions.